Good morning, ladies and gentlemen. This is Dinesh. I'm glad to be here with you today. Further discussions, let's get started since we have only 1 hour. Further delay, I'll start the session. Since today's discussion, we are going to discuss about what is DevOps, what is Azure DevOps, or what is Azure. From there, how we are moving to Azure DevOps, followed by containers, Kubernetes, Terraform, then right into the demo. Like we are going to start doing the demo from how the user stories are getting created, how the developer is going to push the code. Right after that, how the pipeline is going to work. Basically, automation way of taking the code from the repo, and the pipeline will start building the code, and it will go for a deployment. So whole thing we are going to see in the demo in another 1 hour. So to move on, so before getting to DevOps, like before we talk about DevOps, since Ganeshan has set an expectation, like what is DevOps, like before, like what is the real challenge which we are facing in the IT industry right now? So if you could see a developer. David is a developer here, and Peter is an operator. So what does the developer responsibilities? So developer main responsibilities is to, he has some objectives, or he has some objectives has been declared by the product owners or the project team, right? Like, he's gonna do the development and also followed by doing a testing and building that code, finally creating a package, and he will give it to an operational team, right? So this is the developer responsibility. The operation responsibility here is over like mainly setting up the environments, followed by that whatever the development team has given it as a package, right? He has given the code in a certain way, like in a zip file or word file. So the operation guy take that file and he will go and deploy into the environment. You could always hear, or like if we work in IT world, like we'll for sure we'd have heard this kind of things, like developer will always claim saying like the things are working in his local. Let's say he has got some user story, or he has got some feature which he would have worked, he would have nicely presented with the demo or unit test case report as well. Everything works on his local. But the same package or the same code, when you give it to a production, so basically the operator comes, right? Like, or the administration, like instead of operator, I'll call it as admin, like the administrator will come and he will take that package and he will deploy into the production environment. The right after that, we could hear saying like, things are not working in the production. So always there is a wall, like, or the blame game goes between the developer and the operator. Developer says like, things are working on my local, so it's not my issue. So operation team has did something wrong, because of that things are not working. So then operators team, other way, they will say like, no, we didn't do anything. Whatever they have given, like, we have did the installation. We have did the installation as per the mop or whatever maybe, but still the things are not working. So this always the wall was there, right? Between the development and operation team. So this wall is creating a lot of confusion. And here both the teams are not working together, since they are doing their own objective. Here this guy is doing their own objective, since everybody is trying to do their work, but there is no common guy who can manage these two. So to avoid this problem, there is a things have evolved in the market is called DevOps. So it's basically a dev, like from the first three letters it's going to be dev, and from here like it's going to be operations, like ops. So that's where the DevOps is come into picture. And also, if you would have read it in the internet, we always hear saying like, when we heard of DevOps, is like it's something like master and chef or puppet or dockers. It's not only that, like it's not only the DevOps is not only the mastering in any of these particular tools. I mean, it's good to have a knowledge on these tools, chef, puppet or docker, but it does not mean that like that's the whole DevOps, right? Like since as part of DevOps, like there are a lot of other things are also there. Many more tools, or like a lot of other tools. We will see in more detail in another couple of slides, like what all the things gonna be. So what is DevOps now? So from the previous picture, you would have understood like what's the main, what is DevOps, right? Like what was the earlier problem and why the DevOps has come. See here, the developer and operator, they have joined together. So basically, he is a DevOps guy. Like he's managing both the development team and operation team. Now the next question comes to your mind. So which means like a DevOps is a guy who will do the development, will also do the administration, maintenance of the servers. No. So he's not going to do. See, we have a developer here who has to do the coding, right? Like, since the DevOps guy don't need to be an expert in any of the language, or like, basically don't want to do the code. Instead, he has to do the configuration, or basically whatever developer has given, right? We have to take that package, and he has to work with the operation team, or he can do the operation team. So he's not going to do the development. So I just want to make it clear, if you have that level of understanding, the DevOps guy is going to do the develop the web application using Angular or develop the web application using Node. That's not the case. It's going to be completely different. He's a configuration guy. DevOps is a guy who's going to configure all these things. So it's basically, if you could see the definition, it's the union of three P's, like, one is people. So basically over here, what is happening? Every people is working together. That's where the first P comes. Then the next thing is process. We are going to make some process, or like, we are going to follow some process. What is that process? We will see in very shortly here. Then the products, list of products, we are going to process it. What for we are doing all these three P's are combining together to basically all these things are combined together to get the end result with the high quality and also fast in market, right? That's the end goal for all the IT projects, right? They want everything, every project to be delivered at a high quality. So that's with the help of DevOps, we are going to achieve that. And DevOps is always a continuous journey. It's not like DevOps we learned or we implemented today and tomorrow it's going to be the follow same. No, since always it's going to be a continuous journey. We are keep increasing or keep evolving or keep improving our application when and where needed. So let's see here. So the first circle which you could see here is a development. Here this circle represents the operation team. Now we are going to see the fancy words exist in the DevOps world that people would be keep calling CI and CD. What is CI? It's called continuous integration. What is CD? It's called continuous deployment. So let's start with the SDLC lifecycle. I hope since everybody is from IT background, we in the Menti, like we heard like only couple of freshers, like remaining everybody were having a good experience in IT. So I don't want to get into what is software development lifecycle or how the lifecycle works, but at a high level, I'm gonna touch it. Like so when any software or if any project comes in, the very first step what we are gonna do, we are gonna do the planning, right? The project has to plan in such a way that what is the timelines or when they want to deliver, or they want to go with the release 1, release 2, or release 3, release basis, or what basis they want to do it, or sprint basis they want to work on. Everything is going to be part of the planning activity. Then right after that, once the planning is completely done, the developer will start work on one of the tasks or the user stories, or let's say the feature. One feature they will start work on, where they will do all their coding and they will commit their changes into any repository. So combining these two things. So basically whatever the developer does the job here, right? Combining the developer with the planning here the creation is mainly by the developers. The planning is mainly by the product owners or end-to-end architects or even the solution architects or even the project managers, right? So combining these two phases called continuous integration. We will see in more detail, but at least theoretically, you would be getting at what is called continuous integration by this time. Then right after that, once the developer has committed the changes in some repository, it can be in his local or it can be in any repository, right? So once he has committed, next thing what he has to do, we have to do a unit testing. Like, we have to do a unit testing and also kind of an integration testing. Let's say if you have a couple of external systems, you want to test with those external systems. We need to handshake with those external systems whether the things are working well. So that's where this continuous delivery or continuous testing, you can call it a CT in some projects, or in somewhere you could heard the terminology called a continuous testing, CT also. In addition to CI and CD, people may be calling it as CT, like, continuous testing. So over here, it's mainly the testing related things will happen as part of the SDLC lifecycle. So once all this are done, what's our next process? So we are gonna release. So what you are gonna release? See, we have created a package here, right? The developer has committed a code change here that has been deployed in some environment, like, maybe like on a development environment, and it has been verified. Now it's been working. So you want to take that package to other environments like QA or UAT environment or staging or production, something like that. It can be any environment. So basically you are releasing that package. So what is package? This code is nothing but package. We will see the package is nothing but, here developer has written a code, everything in thousands of files. So all thousands files, you cannot take it to a production and you can deploy it, right? Basically you need to zip it, you need to zip it or create a war file or rar file or tar file, some kind of files you need to build that package, and that package has to be get deployed to your production servers. So that's where this package comes. Once this package has been done, then the next thing comes around is you are releasing it. Once you have released it, so basically you are released to some production environment or UAT environment, then which is nothing but, when you are saying releasing, you are deploying into those environments, which is nothing but continuous deployment. So basically the things are, whatever the package has been created, it's getting deployed into the environment. Next thing comes is configuration. What is configuration in the modern world? Earlier days, if you have a development environment, QA environment, or you may be having 5 QA environment, 5 development environment, why 5? Or it may be n number as well. Since every feature, it's all depends on the project or depends on the organization. Every feature, they will deploy it in one environment. So that when we say one environment, it's going to be one development environment, one QA environment for one feature, right? In that case, just imagine if you have a 20 features, operations team would end up creating 20 virtual machines, right? It's going to be, it's a fact, they are going to create a 20 virtual machines to deploy all these features. Just imagine how long it's gonna take, if they want to change or if they want to increase the RAM or any configuration things, if they want to increase in this virtual machine, they have to manually go and do the changes in all this 20 machine. Instead of that, we have something called configuration. There are a lot of tools available in the configuration. You can just write it in the code. The configuration, its configuration would be automatically done. Basically, you don't need to go and create a virtual machine. Even we can automate of creating the virtual machine or creating the Docker itself. We don't need to do that. We will see in detail how that's going to happen. So that's part of the configuration. Then right after that, everything has been set. Whatever developer has developed, it's now tested. Then it's now deployed into the production. So based on the production, you have configured the all the configuration parameters. Now all set. The end user is seeing the application now, right? So basically, the end customer is seeing the application working. Next thing comes like a monitoring. So there is no person who's gonna sit and watch the watch the production server, whether the application is going down or server is going down, or is there any performance or is scale up, scale down, anything needs to be performed. It's not gonna be done by any manual person, or it's not gonna be done by human being. It's everything awesome automated in the DevOps. It's gonna be done by a lot of monitoring tools available in the markets. Those tools are gonna help us monitor. Let's say whenever one virtual machine goes down, immediately we will get an alarm saying that this machine has gone down because of this reason. So once it got notified to the humans, we can immediately look on, or even there are a lot of automation way it can be automatically corrected as well. That's behind this DevOps. So this all things hold together. The whole following of all this process is called DevOps. So once again, so this whole circle is development and the whole circle is part of the operations. Combining these two teams, the DevOps team is evolved, or the DevOps guy who is gonna work on configuring or automating all these things together. So again, here the developer is gonna do their job, tester is gonna do their job here, operation team guy is gonna do their job. So the DevOps guy is gonna do just the configuration or automating all these things together or put it in a proper way. So DevOps, if you have an assumption or perception of is a technology, no, DevOps is not a technology, or not even it's not even a tool or any software, right? It's purely a methodology, processing a set of principles and practices that we want to make it clear. Now let's move on. Why DevOps? So what are all the benefits? When we say why DevOps, what's the benefit we got out of the DevOps? The very first time when you say DevOps, faster time to market, right? Like when you say faster time to market, since you can do n number of deployments in a day. Let's imagine if you worked in a non-DevOps project, if you want to take any code change to a production, it's gonna take week or even a month, right? Even a small change. But with the DevOps, even within a day also, if your DevOps pipeline has been properly set it up, you can do more than 10 times, or I'm saying less, even 10 is also less number. Like, you can do n number of deployments into a production within a day as well, if we have a proper DevOps pipeline has been set it up. Since that's where this whole automation is coming into picture, and it's with the DevOps. So if you could see highly, quickly on the benefits, one is improved monitoring and quicker service recovery. So as I said, like you have a lot of monitoring tools like a Splunk, Nagios, Datadog. All these tools are associated as part of your pipeline. So whenever any system goes down, these tools, automated tools, will let us know like what went wrong, or it can correct itself, like without even letting us know, it can correct itself. So that's where like it's gonna improve the monitoring. Then quicker turnaround of change request. If any earlier days, if any new change request comes, it's gonna take in a month's basis, or like even 3 months to deliver a change request. With the DevOps world, everything is like again with the developer and the uh, operation teams. If they are like the development time is less, it's gonna be the whole process is gonna take to a production. It's gonna be very fast. And other thing with the DevOps is like it's, as we previously mentioned, it's grouping of development team, testing team, and operation teams. So here, or with the DevOps world, all these guys are closely working together. Not only them, like even the product managers, also any monitoring system experts, those guys are also attached with these guys. Then the next thing is continuous delivery and iteration development. As I said, like it's always a continuous delivery. When a developer commits a code in the repository, pipeline would be automatically triggered, which means we are not, once the developer commits any code into the repository, automatically the pipeline has been triggered, which means the build has been automatically happened, and the deployment of to development environment or QA environment, it's gonna be automatically happen without any manual intervention. Again, like deployment to production, it's all depends on the organization and the project which they want to take it. The maybe like you may be hearing saying like a product, the automation CI pipe automation deployment to production is not a good practice as well. It's all depends on the individual organization or the project. Like yes, the automating the deployment to production, few companies may not directly do it, since they will go up to the extent level of QA level or like UAT level. They will automate the pipeline. For QA level, still they will automate on building the packages and everything, but only the deployment, they want some manual approval from customer before they deploy into a production. So all those things can be done. Then reduced operational cost. When we say reduced operational, it's a one-time activity. When I say like one time, the initial time or the initial setup of the project, you are gonna set up all this pipeline. Once it has been set up, any change request or any bugs come, the developer is keep gonna work on the changes and they will commit it. They won't even worry about how the things are gonna get deployed. Since everything is automated from the right beginning, it's gonna automatically taken care. So that's where the operational cost has been drastically reduced, like when compared to the previous one. So previously what happened, every change, let's say 20 guys working in a team, when a single person pushes a change, you need to inform the operational team, or you need to inform the PM has to inform the testing team has to do a testing. Once that has been tested, then the operational team has to be notified, the operational team has to take a package, it has to get deployed into the production, QA environment. So these many processes or these many guys are getting involved. But with this automation, with the DevOps, it's everything is automated. Nobody is getting notified. Once the developer pushes the code, automatically goes to QA or it's getting deployed. So automation build will run using Selenium or some other tools. The results will get generated. If the result is failure, the deployment may not also happen. We have that much level of automation can be controlled. If the deployment fails, if the automation fails, The deployment will not even happen to the further environments. It will stop right over there without asking somebody as well. That much level of automation could be performed in the DevOps. So let's move on. So what are the most commonly used tools available with respect to DevOps in the market? So these are all the most commonly used tools. Again, these are some of the most commonly used tools. Again, there are a lot of plenty of tools for each operations. Like let's say for coding, like you have a GitHub or Bitbucket, lot of things were there. It's like what we captured it over here. It's a very minimal tools. Like this, there are each module or each in the SDLC lifecycle, everything is gonna have plenty of tools. So at a high level, let's quickly take a walk over on these tools. So the coding is basically done by the developer, right? The coding, once the developer did the coding, he's gonna commit it into some repository, or he's gonna commit the changes into some version control tools, right? It can be like a GitHub or a Bitbucket or a lot of plenty of other tools, right? Those places you will commit. Jira. So what is Jira? Again, everybody knows, over there it's going to be it's an ALM tool, application lifecycle management tool, right? Over there you are going to capture all your things, like with respect to the user stories or defects, or how many times how many times the defect got rejected, or what was the time has been taken for delivering a feature, or the user story bug. Everything has been capturing as part of the above application lifecycle management tool. Confluence, all your documentations can be kept it as part of your documents. So here, in our SDLC, the code can be performed, or planning and coding can be done by the most commonly used tools like Jira and Confluence. I hope if you worked in IT, hope everybody would have heard of these tools, on our day-to-day life. Then the building tools. So let's say the code has been written. When we say code can be there are a lot of teams, right? Like a front-end team, back-end team, middleware team, and not only teams, every team can use different languages or different platforms can be performed, right? Let's say like a front-end, in some projects they would be writing the code in the Angular. In other project they may write it in the React. Same goes for the backend. Backend, some project they may use Node, or some project may use Java, some project may use .NET, etc. This is just an example. As I said, again, the count is it's gonna keep going infinite. We cannot even count it. So now, what is this build? Since let's take two scenarios. One, the front end code has been written in Angular, and the backend code is written in Java. So if you have the code has been written in Java, and the code is there in your Git repository. What this Maven tool is gonna do? This tool is mainly for building the Java projects. Maven tools are mainly to build the Java projects. So if your code is written in a Java and is there in the Git repository, using Maven tool, we are gonna build the code. Right? If it's an Angular or any front end, any JavaScript, we are gonna use npm. Node package manager, right? Using npm, we are going to build the codes. Same way, there are a lot of tools, guys, which we can use it to build all our codes based on the technology which we have used it in our doing the coding. Then followed by testing. Testing also can be performed by a lot of tools. One is Selenium, mainly for automation, JUnit, then Cucumber, Robo framework. It's countless again. Using all those frameworks, you can do all kind of testing. Automation testing can be performed. Then the release. There are a lot of release management tools. One is the most, from the decade we know, Jenkins is one of the most widely used tools in the market for the release management tools. There are a lot now, the GitLab, which were really evolving now, where they are trying to automate all these things. Even the Git also, GitHub, instead of storing it in GitHub, GitLab is having their own repository, own cloud repository, where you can store it. All these things can be taken care by GitLab as well. Again, it's that's one of the tool I'm talking about in the release management. As like Jenkins, we have a GitLab. We have one more thing called Circle CI, which is also evolving now. Then the old tool which we know, Atlassian Bamboo, for doing the release management. That's one of the tools. And followed by, we have a deployment. When we go for a deployment, we are going to go with any cloud related things. As I said, like, the deployments now, we have an Azure container instances. AWS is also supporting, Azure is supporting, Google Cloud is supporting the deployment related things, which means they have their own inbuilt, customized version of this Dockers and Kubernetes where you can go for deployments. So again, for deployment, we are most commonly used as tool as a Docker. Then operational related things, basically the configuration which I was talking about the previous slide, all the configuration can be automated using Chef and Ansible. Again, here Ansible is very much properly used for last 10 years for all the operation related stuffs or all the configuration related stuff. Kubernetes, if you are using a Docker, it's mainly going to help you for doing the orchestration. Kubernetes helps for doing the orchestration of your Docker containers. We will see like what is this like in detail about if time permits. We'll see like in detail about what is Docker and Kubernetes. We have a separate section today like where we are going to talk about all these things. Then the monitoring tools, we have a Nagios or Splunk or Datadogs to do the monitoring. So now after seeing this picture, there may be a question popped in your mind: am I gonna learn all these tools? Or if I learn all these tools, then only I can become a DevOps engineer? The answer is gonna be no. Like you don't need to learn all these tools, but it's good to have a knowledge of all those tools. And see, this is where the if you are using any open source, like you need to integrate the Git with the Maven. You need to integrate the Maven package with the Selenium, right? You need to integrate the Selenium. Jenkins has to take the package from Selenium. All those things you need to integrate. That's where we are moving towards some cloud provider DevOps. Over there, it's all these things has been pre-integrated. You just need to know few of their terminologies and few of their major one tools for each section. That's going to help us automating the complete DevOps. So let's move on. Now let's see like what is Azure DevOps. I hope we got like what is DevOps so far, right? What are the challenges or like why we moved to DevOps. Now let's see what is DevOps. So here you could see DevOps. Azure DevOps is a software as a service. What is meant by software as a service? It's a kind of a new terminology. So if you worked in a cloud environment, any cloud-based environments, there are three mainly used services in the cloud with respect to any cloud providers. One is IaaS, infrastructure as a service, PaaS, platform as a service. The next one is software as a service. Let's quickly see like the difference between these three. What is this all about? So infrastructure as a service, to have or to use those cloud service infrastructure as a service, the very first thing you need is like you need a technical knowledge, which means over there they will be giving you just only the virtual machine. Then once they have given, I'm just taking virtual machine as an example, as one of the example for IaaS is virtual machine. So basically the cloud providers will give you the virtual machine. On top of that, basically it's a laptop. Like virtual is nothing but it's kind of one laptop. So on top of that, you need to go and install Java, Oracle, or NPM, whatever you need it. Like you need to install, you need to automate everything. So that's with respect to IaaS. With the product as a service, what's that about? Sorry, platform as a service. It's required a knowledge of subject to understand the basic setup, but it does not mean that you need to have 50-50. Like you need to be 50% technical and to do the setup. Since platform as a service, you will get all those things. Like let's say SQL database. Like SQL database, if you go to any cloud, they will be giving SQL database in an option. You just click on it, automatically it help you to create the SQL database. Just give the username and password, it will set it up for you, everything. But if you go and install local, you have to install it and you have to set it up, everything you have to do it on one. But if you take it under the platform as a service, it's everything, it's taken care by the cloud providers. Then the last one, the beauty of is software as a service. There is no requirement about the technicals. Doesn't mean that we shouldn't be, we should, without technically we can do something, at least little bit. It's more than enough, like to handle everything with respect to the software as a service. These are the three major cloud-based services available with respect to all cloud service providers like AWS, Google Cloud, or even Oracle Cloud, uh, yeah, Microsoft Azure. So basically, what is Azure DevOps? So it's a flavor of DevOps, or basically Azure DevOps is a product by Microsoft. So they have taken couple of tools, or like they have taken couple of tools and they have pre-integrated all those services. I'll not say it as a tools, I'll call it as a services. Let's say like a Jira can be one service, Git can be another service. So what they have did, they have pre-configured all these services together. So it's up to you whether you want to take that each service or not. Basically, like you may interested to go with Jira, right? Like you may interested to go with Git, or you may interested to go with the Jenkins. It's up to you. Like a DevOps, Azure DevOps is providing a flavor of all these things. Whichever you needed, whichever the service you needed, we can take it. So as a DevOps engineer, if we are planning in such a project, we can decide ourselves which can be more beneficiary to the organization based on our experience, like which services we can take it. And not sure like if somebody has worked in Visual Studio Team Services. In September 2018, the Visual Studio Team Services is renamed to Azure DevOps. Before that also, DevOps were exist in the Microsoft world, in the Microsoft Cloud world, but it was called as Visual Studio Team Services. So in Azure DevOps, what they have did, they have renamed, when they renamed the whole service name itself, like, from VSTS to Azure DevOps, they have renamed their services as well. Previously in VSTS, if you take an example, they will call it CI and CD as build under release, but now they are calling it as one word called Azure Pipelines. So basically the functionality remains same, only the name change has happened on September 2018 to Azure DevOps. And what's another benefits which we with the Azure DevOps? As I said, like Azure DevOps already providing a lot of out of the box, they are supporting a lot of things. In addition to that, you can customize or you can integrate the another third-party product seamlessly without having any challenges. That's the another benefit with the Azure DevOps. So Azure DevOps has a marketplace. In the marketplace, you could see almost all of the third-party tools where if you are interested to integrate your services, even that can also be feasible. So why Azure DevOps? So now we have seen what is Azure DevOps. Now we are moving to why to Azure DevOps. So if you could see, like, previously we have touched upon, this is on-premises, which is basically on-premises environment. And this is cloud environment. Basically, it's an Azure cloud. What is hybrid? It's mixed. Like, I want to take 50% of Azure and 50% of cloud and 50% on-premises. That is called hybrid. Now, if I want to give an example for this hybrid, a lot of companies, they don't want to use the cloud. I mean, when they want to use the cloud, but they don't want to use the complete cloud. Why? Because they don't want to store their customer data on cloud server. It's mainly applicable for government organizations, like, they don't want to store their data on any cloud. Even the cloud is always secure, still they don't want to do that. They want to store their data alone in the on-premises. Remaining things, they are okay to go with the cloud. That's where the situation hybrid comes into picture. Even Azure DevOps support all these things. You can go completely with on-premises, or you can go with a hybrid model, or even you can go with a cloud-based model. So when you go with the cloud-based or any model, so you could see there are a lot of services coming out of the box where you don't need to do any customization or any installation is required. Since everything is out of the box, you just need to start using it. See, the multi-factor authentication is already provided, right? A two-factor authentication, or like it's a multi-factor, not even a two-factor. Then followed by directory, Active Directory, AD, like, almost now everywhere, like every company has started moving towards the IAM, right? Identity Access Management with the Active Directory pre-integrated with the SSO, single sign-on, right? So these things are already pre-configured with respect to the Azure DevOps. So it's like a plug and play. You can start using it, and you are gonna pay for the service when you are using it. Let's say if you're not using the
virtual machine for now. So you can just stop it. Like, once you stop it, there is no charge associated with it. When you start reusing it again, how many minutes it's gonna run? Only for that the charge is gonna get charged. So that's where, like, it's basically mix and match. You can go with any of these things. So that's another beauty behind the Azure DevOps. There are two types of server configuration can be exit. One is, like, as I said, like cloud, and the other one is on premises. So with respect to cloud, our Azure DevOps services is going to help, where we are going to mainly look toward. But if you have an on premises and you are trying to go with the DevOps, Azure DevOps, you need to use Azure DevOps Server. There is something called Azure DevOps Server, which is mainly for on-premises. But if it's going to be cloud, we are going to use Azure DevOps Services. Now let's see about what are the list of services available in the Azure DevOps. So yeah, the services available in the Azure DevOps these are the main 5 services available in the Azure DevOps. One is Azure Board, and the other one is Azure Repo. The third one is Azure Pipeline, Azure Artifacts, and Test Plan. So now we will see in detail about each of the services. So this is the most important thing. Like, by learning all these 5 services, you can be you can completely automate the pipeline in the DevOps world, starting from customizing the Jira board or a Kanban dashboard, like, creating the repository for the developer or the tester, creating the branches, release management, and everything. Right after that, automating the pipelines, then the artifacts. We will see in detail, like, very quickly, like, we will see in detail about all these things. What is Azure Boards? So if you have a multiple teams working on a project, right, those teams need to communicate better. How are they going to communicate better? Using this kind of any one of the application lifecycle management tools, right? So Azure Board is one of the application lifecycle management tool, as like the Jira. So over there, it support, like, work items, boards, like, backlogs, sprints, and dashboards. So I don't want to go in detail of all these things, since from the initial I understood everybody is having IT background. So you guys would be knowing all these things very well. And Azure is using Azure is also providing a native support for Scrum and the Kanban boards, where you can do all your where you can view all your day-to-day activities, as well as the task burning, sprint planning, capacity. Everything can be viewed over there. The next thing which we are going to see is Azure Repo. So I mean, Azure Repo, as I said, like, repos are nothing but repository. Think of it's a home, like, its home is a place where you are dumping all your things, or, like, even we are living. In addition to that, all our stuffs are going to be there inside the home. So it's the same way. Azure Repo is like a home, or it's a storage for a repository, if I want to compare it. So here you can do all these things, like, you can basically you can do the files. Basically, you can have a n number of files in the repo. You can do a commits, push, like how to push into the repository, then how to create a branches. What are all the branches we can maintain? Hotfix branch, production branch, master branch, development branch, release branch. What are all the best practices to be followed, or how to merge from a hotfix branch to master branch? Everything we can see in detail as part of our class. Like, we will also walk through about what are all the different types of branching strategies available, and also teach about how to all the code, what are all the commands to use to push the code or commit the code, or how to revert, or how to do a merge conflict, followed by how to raise a pull request. Like, how to resolve, when we say pull request, it's basically, I'm one of the developer, I'm working on something. I may be new to this team, so I'm working on something, but I don't want to push my changes directly into my master branch or my main branch. So pull request is nothing but I will raise a merge request, or nothing but a pull request. It has to be approved by my tech lead or team lead, or one of the SAs, like, to merge that code to a master branch. That's nothing but a pull request. So again, Azure is supporting two types of Azure is supporting two types of version control system. One is distributed version control, and the other one is centralized. So for example, distributed version control, the best example for distributed is Git. What is distributed version control? Here, every developer will have a local copy of the repository. Basically, you have one main repository. right? One central repository. So let's say 10 developers are working, 10 developers clone the repository from the main repository and they will have it in their local. So they will commit everything on their locally. They are not committing anything directly into the central repository. That's nothing but distributed version control. When we say centralized, you have only one centralized copy. So basically developer cannot maintain the local copy here. So when they want to commit, they are directly going to commit into the central copy. That's called central copy. Maybe like when I started working, I have worked on SVN. So SVN is one of the best example for centralized version control. But now the world is more towards the Git, which is distributed version control. So again, you may have question, like there are a lot of repos are there, right? Like GitHub, Bitbucket, Atlassian Bitbucket, but still why Azure Repo? So here it's basically a cloud. It provides you unlimited cloud hosted private Git repositories. So you can have a unlimited private Git repositories. So this service, that's the main advantage between the on the Azure Repo. Next we will see the next third service called Azure Pipeline. So now the new term comes pipeline. What is pipeline? In a simple term, if I call it as pipeline, it's a combination of continuous integration and continuous deployment. So now you have a question, what is continuous integration and continuous deployment, right? So you could see here. So basically, this is your repository. In our case, this is Azure repository where developer commits. So here one developer sits and he will commit the changes into this code repository. Next, right after that, what is happening? He's raising a pull request or merge request, right? He don't want to commit the changes directly into the main branch. So he's raising a pull request. So the lead is going to approve or reject his request based on the code quality. Once this is done, it's getting merged to a main branch. I hope it's clear so far, right? So once this has been done, so the code is there in the Git repository now. Next thing comes CI pipeline, continuous integration pipeline. What it does, it will directly go and take the code from the Git repository and using one of the build tool, as I was talking about a couple of build tools, right? Maven, NPM, NuGet, all those tools, right? Using one of the tool, the code is gonna get built, then it's gonna get tested. See, the code is getting tested here. Basically, the unit testing or the automation testing is gonna get performed here. Once it has happened, we are going with the Sonar Cube or Sonar Cloud, whatever it may be. So this is again another tool where you are gonna do all your you are gonna check all your vulnerabilities or code smell, or like this tool is gonna verify all your technical depth. Is there any problem with the code, or with the coding standard has been properly followed? Everything is gonna be validated by this tool called Sonar Cloud or Sonar Cube. Let's say we have passed until here, Sonar Cloud has failed that step, saying like, hey boss, whatever the code you have committed, it's not up to the standard. So this Sonar Cloud has committed, so it will not gonna proceed further. It will fail there itself, and this developer will get notified saying that the build got failed. Immediately the developer will start work on and they will fix again. It will go to Sonar Cloud. Once it's success, it will move to the other tools. Like White Source is another tool which will check all your security related things. This tool is mainly useful for, let's say you are using n number of third-party libraries. You may not be knowing whether the third-party libraries are having any license, or they introduced any license now, or anything like that, right? Or any such vulnerabilities. It's going to be identified by this tool, White Source tool. It's mainly for the security testing. Then these are all the things getting performed in the CI. Once this is done, so basically what is the end product of CI? You are gonna get one package, right? So basically you are gonna get the build package. So end product of CI is nothing but one package. That package can be in any format, zip format or RAR format or WAR format, right? Like any kind of format. That it's gonna taken to development environment, QA environment, staging and production. This is called CD. By this time, hope everybody is clear now what is CI and CD, right? So if you look into it like in detail, this is going to be the services. So basically, developer take one of the user story from Azure Board. He will using the Visual Studio Code. He will work and develop, push the changes. The build job is going to do all these things. See what it's doing. It's basically getting the source from here, then required tools is gonna get install it, then gonna build the solution. Artifact, the next terminology which we are hearing, something called artifact. What is artifact? It's nothing but a package. I talked about the zip file or WAR file, right? The new name for that is called, the package is called artifacts. Instead of calling it as package, now the world is towards artifacts, calling it as artifact. So that zip file or package file is called artifacts. As I said, like what is the end product of CI? What CI is gonna give you the end result? It's gonna give you the package. That package is called as an artifacts now. So now we can call it as the end product of CI is artifact. That artifact would be taken by CD, right? The artifact would be taken by CD, and it's going to get deployed into the development environment or QA environment or production. In production, you could see here, there are a lot of new deployment models coming into picture now. There is a canary release or a dark launching, or even now hot in market with a blue-green deployment. What is blue-green deployment? So basically, you have two production environments or one production replica environment. Blue is always your production environment. Green is exact replica of blue. So it's this one is blue, this one is blue, and this one is green. So it's exact replica. So basically, what will happen? Whatever the new feature you are gonna bring it, you will deploy it in green, and you will do a complete round of testing. If everything goes good, you will just swap the environments. So basically, from the end user perspective, he would be seeing the same URL. He don't see whether it's going to the blue environment or green environment. The end user perspective, the URL remains same. The load balancer is gonna route it to blue or green. So with that way, the new deployment pattern is also getting satisfied. Next thing we are going to see about Azure Artifacts. We already touched upon what is artifact. So it's basically end product of CI, which is basically a zip file or WAR file. So these are all the commonly used tools where you can build the artifacts. One is if your code is written in a .NET, right? Then you need to use NuGet as a tool to build the WAR file or zip file. Then if code is written in Node.js or any JavaScripting, so it's going to be npm is going to get used. If it's written in Python, then we will use a Python tool. If it's in Java, then you will use a Maven. For Docker images, if you are using, then you are going to use a Docker. The universal package which you want available in the market, this is something specific to Azure Artifacts. So this is if some of this, any of these tools couldn't be performed, then universal package is going to support on building those frameworks, or if it has been written in some other language, using universal package you can build it. The last one is called test plan. So we have seen 5 services so far. So the last service is test plan, where you're gonna see the end results, the testing results via the manual testing or automation testing. It's gonna give this the dashboard of the test plan. So it's gonna say you overall execution state, how much you have executed so far. Test automation status, how much the test automation testing has been executed. Testing ownership, who has taken the ownership. Let's say Dinesh, how much % he has taken, and how much is contribution, how much is execution rate. Everything can be, all this dashboard also can be customized in the Azure world, like Azure test plans. So far we have seen 5 services. That's what I said, those 5 services are the most important thing. Now let's see a IT world with the whole life cycle, how these 5 services are getting integrated. Now let's take an example. So the step number 1, customer comes with an requirement, right? Any customer comes with an requirement. Next thing, who is the guy who's going to start work on? The business analyst or the product owners, who is going to closely work with the customers, right? So once they have worked with the customers, they will start creating, or they will get the requirements in the form of backlogs, or they will start writing the backlogs, or they will put it into the backlogs in the Azure Board. As I said, this green represents Azure Board, which is nothing but an application lifecycle management tool as Jira. So all these things would be put it into the backlog. Now our engineering team, basically our end-to-end architects or architects, start drilling down that backlogs and adding much more information to that, right? Once they have added much more information, and they will add into the Azure boards. Then the developer, then the next step, what has happened? The developer comes in. Just a minute, I need to admit one person. So next step, like what is happening? So the developer will start picking the user story or the task or the bug from from the Azure boards, right? As I said, like this, like as equivalent like Jira. So he will start work on it. So using Visual Studio Code, again, it's a Microsoft product. Like, the Visual Studio is developed and released by Microsoft. It's an IDE, integrated development environment, where you can, do all your coding. So using any one of the tools, this is an example here, like, it can be anything, like using Eclipse or IntelliJ, using any one of the tool, developer do their coding and they will commit the changes into the repo. This is repository. Our second service, Azure Repo, the developer will commit the changes into the Git repository. What's next? Once he has committed the change, Azure Pipeline, what it's going to do, it will go to the Azure Repo and it will take the latest code from the Azure Repo and it will start building it. As I said, like we have seen something called Azure Artifacts. There are using build tools, we are gonna build it, right? Once that has been built, that's the end product of your CI, where basically once your build product is called artifacts, right? That's getting stored here, Azure Artifacts. Once that's done, next thing is coming to CD. That is step number 7. You are gonna deploy it, right? You have, as part of Azure Pipeline, you have two things. One is CI and CD. So next you are gonna do the deployment. Where you are going to do? You are going to deploy into your testing environment. See 7.1, you are deploying into testing. Let's say once you have deployed, immediately tester notified a lot of bugs as part of this build, whatever we have given. Immediately what is happening? Step 8 comes. Once the build is deployed, testers start testing it and log defects, if any, in the Azure board. So testers started creating the defects in the Azure board and they will leave it here, right? Then the developer would get notified, since they have when they are creating the defect, they have taken which developer has fixed the, or which developer has worked on that feature. So he will get notified. He will start taking the bug from Azure boards and he will start work on using this tool. Then he will commit into the Git repo. Then automatically pipeline runs. Like once he has pushes the code, automatically the pipeline runs. The build will get created. The artifact has been come. Now it's going and deploying into the testing. Now let's assume a case everything has went through, no defects. What next? So tester has certified saying like all good as part of this build. Next we are going and deploying into the UAT. So UAT, it's a universal acceptance, user accepted testing. So that's one of the most needed testing before we release the product to a production, where the business owners or the the business users are gonna test our application, right? Since they were the one who is gonna use the know the application very well, so they are gonna test the application. So see, after once it's got deployed in UAT, then step number 10, the business users are going to test the application in the UAT environment. If they notice an issue, what they will do? They will raise a bug in the Azure board. Again, the cycle follows. Developer will start work on build, pipeline will run, then it will come and deploy in the UAT. Now, in this case, in the next case, like a business user does not see any issue in the UAT. They are saying like no defects. They certified or they handshake saying like everything good. Then it's automatically taken to a production. So once it got deployed into the production, everything good. So we are closed. So if you could see here, all 5 services, Azure 5 services are getting used. Azure Boards, Azure Repo, Azure Pipelines, Azure Artifacts, and Azure Test Plans. So all these 5 we have integrated. We have prepared this the diagram to link all these services together, how the DevOps is going to automate all these things together. Sections. So what we are saying now, choose the tools and the cloud you love. So basically we are not restricting. Here you could see this is Azure Boards, right? And this is Azure Pipeline, but we are not using Azure Repo. Instead we are using GitHub. So this is a GitHub, right? So basically one team has started using Azure DevOps, but they are going only with Azure Boards Pipelines. They are not going with Azure Artifacts, or they are not going with Azure Repo. Just only these 2 services they used, and they used an Ansible or the extra. But here the another developer, if you could see, they used Azure Repo and they used the test plan and they used the Azure Artifacts, but they didn't use the Azure Pipeline. Instead they used Jenkins as a release management tool. Since Azure Pipeline is a release management tool, right? Instead of release management tool as Azure Pipeline, they went ahead with the Jenkins here, right? That's where, like, it's just an example. So what the recommendation from Microsoft, you choose any tools, or you don't need to, you can pick any one of this, or remaining things you can integrate with anything which we know, or which you feel like comfortable with, or which you see like that third-party tools is going to give more value added, that can be feasible in the Azure DevOps world. And again, same goes with the cloud as well. So you can choose any cloud for a deployment, or any cloud you can use it, but still you can use Azure DevOps as well. Like, that's where we are saying you can select any cloud you want to target, any cloud on premises or both, and deploy to the server you need. Okay, quickly moving back. So we would be touched upon, like, containers and the Dockers. Quick an example here, like, just wrap it up, like, a couple of things, then we'll get into the demo. So here you could see containers and VM difference. So this is a virtual machine. What's a virtual machine? Before virtual machine, let's take an example. Your system, like your system is nothing but on premises, right? Like, so basically you have your laptop. Inside the laptop, you have your OS. So all your services, whatever you are going to, install inside it, everything is going to use the same OS. But with respect to when you move to a virtual machine, so you have your same laptop, but you have created multiple images, like using images, virtual images, you created multiple machines. So basically the guest OS, like, basically the hardware is getting shared, but you can install any OS here. So this is one virtual machine. The red one is second virtual machine. This is third virtual machine. So here, what is happening? Basically, the infrastructure is getting shared on these virtual machines, but not the operating system. You can install any operating system. Let's say an example. Your laptop is, this is your laptop, your infrastructure, right? Your laptop is having Windows OS. It does not mean that if you are creating a virtual machine from your laptop, let's say you created 3 virtual machines from your laptop, doesn't mean that you need to have your OS for the virtual machine should be Windows. You can install any OS you want. That's the benefit with the virtual machine. But the problem with the virtual machine, what's the problem with the virtual machine? Why we move to container? Let's take this virtual machine as an example. I have deployed an application. Let's take an example. I have deployed an application where my application need one software version with specific version. Let's say I need a JDK 1.8, right? And 2 of my application is dependent on the JDK 1.8. In that, one application needs JDK 1.9, another application needs JDK 1.8. Now, your application, if within a virtual machine, what will happen if you currently you have 1.8 as a JDK? If you increase it to 1.9, your next application will not work, right? Only one application, since one application is dependent on 1.8. So that's the problem with the virtual machine. Now let's see, like, how this is getting resolved, or, like, what Docker is giving benefit out of it. So here what is happening, same again, you have your laptop. Here what is happening, you don't have an operating system constraint here. Basically you can install any app you want, since it's gonna share the operating system of this one. It's basically the kernel operating system is gonna get shared. So here each container is not having any OS, since it's sharing the OS of your host or the kernel, right? So see here, this is Docker 1, this is Docker 2, Docker 3. You have application only installed, but you don't have an OS. So the main difference between these two, see, you have a OS. Always if you have OS, like, the first thing, it's gonna have a heavy load, right? Like, the more space is getting consumed, nearly 2 GB, 3 GB, the OS itself will occupy. Here it's no. Second thing, booting the OS always may take seconds, or it may take a minute as well. But Docker, the restart of Docker is going to be in a fraction of seconds. Like, since we don't have any OS or anything over here, it's going to be a fraction of seconds. So we will see in detail in our class with the live demo how these things are going to work, or how to create a virtual machine, and also how to create a Docker, and how to write a Docker image. From the Docker image, how are we going to create a Docker container, everything in detail. The next, Azure Kubernetes service. So Kubernetes, again, it's an orchestration tool for managing all your containers. So that's the main Kubernetes into the picture. So again, Docker, Kubernetes, it's all separate vast area. It's like a sea, like, in addition to DevOps, these are all separate certifications also there. But yeah, as part of this, like, we are gonna learn like what is this or how to integrate all these things, but we don't want to be a master of all these things, right? We don't want to be a master, since then the DevOps guy is gonna be master in everything. So it's not mean that, like, we need to be master in all these things. At least we should be knowing how these things to get configured, like, using the configuration itself, right? So again, Kubernetes, Azure, it's Azure version of Kubernetes is called Azure Kubernetes service, where most of the things is owned and managed by Azure. We just need to manage the worker nodes, all your master nodes. I mean, if you are not getting what is master and worker nodes, we will see in our class in more detail. But at a high level, most of the things are managed by Azure. That's where it's called Azure Kubernetes service. Then the next thing which we are going to see about infrastructure and configuration as a code. So what is this? Like, there are a lot of tools available in the market. One is Chef, Puppet, Ansible, and Terraform, which is really, really hot in the market now, where they are trying to build an infrastructure without doing the manual step. What is this? Like, how they are creating the infrastructure using the automated way. Say again, the developer here, or it may be an operation developer. So far we have seen a developer who writes a Java code or Angular code. Here a developer who writes a code in the JSON or in the YAML, like, extensible markup language, where he will write the code in the those permission. Again, he will commit the code in the any one of the version control. Once he has committed, your automation server will take that and it will start creating the resources. So in the YAML file or in the JSON file, you can write what resource you want to create. Let's say you can create a virtual machine also. So you can say what is the name of the, let's say you want to create 100 or 1000 virtual machine. Create one YAML file. In that YAML file, just say, like, I want to create a virtual machine. Declare a global variable over there. Increment the each virtual machine name by 1. Right? So once you give that code, automatically it will create 1000 virtual machine within a fraction of, or within a minutes, like, but imagine, like, if you want to create 1000 virtual machine manually, how long it's going to take. Even in the cloud also, how long it's going to take, right? It's going to be really time consuming. But with the infrastructure as a code, everything has been automated. And I just gave an example as a virtual machine as an example. Even for SQL Server, SQL database, or your SDN or virtual network, anything can be feasible as part of the infrastructure as a code. So last, we are going to see about dashboard. Azure is providing the Azure dashboard, where you could see, like, everything with respect to your application, security, infrastructure, everything you could see it. Just an example. Let's say you are, as I said, like 1000 virtual machines are running your machine, and you don't want to manually track like each virtual machine. So in the application monitor, there is something called application monitor in Azure, which is gonna monitor your application, which is gonna monitor your guest OS, which is gonna monitor your resources. Let's say, like, a virtual machine is one of the resource, right? It's gonna monitor all the 1000 virtual machines, like, data about the operation of Azure resources. When the virtual machine goes down, or how to reboot it, everything is gonna be monitored. Everything with respect to application or with respect to resources, anything can be managed using Azure dashboard. So it's everyday, day-to-day life for a DevOps engineer to log in once and see, like, what's happening on the day-to-day life. With respect to the monitoring of the application. So it can be scale up, scale down, anything could be monitored. Again, this dashboard is a customizable one in Azure world. Whichever you want it, let's say you want to monitor only the application related things, you can monitor it. You can customize and keep your dashboard all related to application. Or if you want to check about security, you can keep it. So this dashboard is customizable one. So no further delay, I'm getting into the demo now. So let's quickly see, like, how to, as part of this demo, I'm gonna create one CI pipeline and one CD pipeline. We are gonna run the CI and CD, and we'll see in detail. Okay, Ganesh, thank you. So yeah, so let's move on. So before I move on to the demo, I just want to show, or I just want to give a quick overview what we have discussed so far. So we have discussed 5 services. One is Azure Boards. So this is the portal. This is the portal for Azure DevOps, dev.azure.com. See, the first thing you could see Azure Boards, Azure Repo, Azure Pipeline, test plans, and artifacts. Now we are gonna see a demo which combine all these things. So for time being, save the time, I already created one project, or basically I have created one .NET project and committed the code in the Git repo. That part we don't need to be do, right? I mean, nobody is interested for that as well. So I have list of boards, like, if you could see into my boards, I have a lot of defects, right? Like if you could see, like, tester has already raised a lot of defects for me. Like, you could see like epics, features, task, right? Like a task. So you could see in the Azure boards, like bug, user stories, epic, task, everything, right? Here is the place, like all your work items. So work items, every entity in the application lifecycle management is considered as work items in Azure world. So basically a bug or epic or feature or user story or task, everything is considered as work item. So work item is the place where you could see all your task over there, or all entity over there. Next thing is boards. So you are gonna see what all the boards are there. So with respect to us, see, I have this board, like, where in this board we could see like what is the task, like, what's the start date of the task, like, who is working on, what's the priority of the task. Let's say if I want, I can move, drag and drop, like, definition. So as a DevOps engineer, we are gonna create this board. Or let's say tomorrow the team may ask, can you introduce one more new column here, like, as like expirate. See, all when you see like expirate, like usually you won't see it in your project, right? You could see new, doing, develop and test and done. But expirate, whenever a tester could see an expirate, an item in the expirate, they have to start work on. That's where this expirate. So all this customization of the board is going to be part of the DevOps engineer responsibility, and we will teach you, or we will help you how to customize all these things as part of our main classes. Then you could see the backlogs, what are all the list of backlogs available for the users, where we can start work on, or we can plan for any sprints, like, it can be planned on current sprint, or it can be planned on future sprints. So you can see here there is an option shows like epic or features or backlog, which we want to see, everything you can view it over here. Then sprint, here it's going to show you the current sprint. What is your current sprint and what is the current sprint number? Currently I'm in sprint 2, and current sprint shows these are all the tasks exist now. So I'm gonna move, saying like I have worked on this task, like it wasn't to do, I'm doing in progress, then finally I moved it to completed. So I'm done with the task. So this way, like this is a Kanban board where you could see all your day-to-day activities, where you can on based on your name you can work on, and move your task accordingly. So this is with respect to boards. Then let's move on to the repos. In repos, what we are going to see, repos files is going to show you list of files, whatever, or list of developers, whoever has committed the file so far. Then commits, it's going to show you like how many commits or who has did the commits, going to history of commits, who has made it what. Then pushes, it's going to say like, who has pushed, the last push has been made. With respect to that, you could see it over here. branches, it's going to show what all the branches we are creating. So by default, the default branch is going to be the master. From there, we are going to start creating demo start or UI test, like a lot of branches we are going to create on and we can work on. This is with the branches. Tags. So whenever you take any changes to a production, right? Like whenever you change, you're planning to deploy into production, you need to create a tag saying that this is the tag, so that tomorrow when you come back or if you face any issue in the production, using this tag itself, you can create a new branch. That branch is called hot fix branch. So you can you can say like a git checkout the tag, like it's gonna create a git checkout tag, like it's gonna create a new branch which is like whatever there in the production, where you can fix your changes or like fix your issue. Then you can merge it back to your master branch and take it to production. Then whenever you are taking to production, again we need to create a tag. We will see in detail all those things like in our class. I don't want to spend much time here. Let's move on to the pipeline. So under the pipeline, we have two things. One is, see, this is main pipeline. Inside that, you have something called pipeline and releases. So this pipeline represents CI, continuous integration. This pipeline represents CD. This is going to be, so this releases represents CD, continuous deployment. See, you could see, I already have continuous integration created for me, but which I'm not going to use it now. Let's create a new pipeline for our demo. So click on a new pipeline. So it shows like where is your code comes from. Code is going to come from Azure Repo, or it's going to come from Bitbucket or GitHub or any other Git repository, or it's going to be a SVN. I told you, right? Like there are two different types of version control. One is distributed and centralized. So whether you can take it or you want to, the pipeline can be created by two means. One is if you are good in YAML language, then you can create it using the code itself, like using the keywords you can create it. But if you are not good enough on creating using YAML, Azure DevOps provide another way using the UI. With the UI, you don't need to know any commands. Everything is going to be on the UI itself. Just click on button, click. So you could see here, for today's demo, I'm gonna take an example creating the pipeline using the UI. So I'm going to use the classic editor to create a pipeline without YAML. So click on it. So I'm creating a new pipeline. So it's asking where is your code comes from. It's coming from repo or hub. So for me, we know like it's coming from Git repo. So I'm going to stick with the Git repo. For your case, if it's anything else, you can switch it back, right? So for me, it's going to come from Git repo. So I'm going to continue with that. And it's going to ask you select a template, like, in which language your code has been written. Like next step, we need to build it, right? What is CI? In CI, the very first step is you need to build the code. So based on the language which you have written, you need to use the appropriate tool to build it, right? So you could see here, lot of tools like, Maven, as I said, like it's used to build the Java code, right? And Python. Ant is one of the most popular tool which can use for building, right? And see, you could see a lot of tools. So in our case, I know my code has been written in .NET, so I'm gonna do with ASP.NET, right? So I'm selecting it as ASP.NET. So here it's asking the name of the CI. What is the name of the CI pipeline you want to give? I'll just keep like this. Like this is my project name. I'm gonna call this as CI my end, right? All set. So you could see here what all the jobs it's gonna perform. It's gonna use the NuGet as a tool, which is a build tool for .NET codes, and it's gonna restore. Then it's gonna build the solution, followed by it's gonna do a testing. Then it's gonna publish an artifact. As I said, like the end goal of CI, continuous integration, is publishing an artifact, which is basically a zip file or WAR file. So I'm not gonna do anything. See, I just selected what's the build tool. I'm just gonna save. I'm gonna save and queue, which means I'm gonna start the pipeline. So you could see here, I didn't do anything. I just configured the pipeline. So for now, you could see the pipeline has started. The CI pipeline has started. It shows consumed. What does it mean? If you click on it, it has consumed the code from the Git repo. What the symbol represent? Git repo. So basically, it went ahead and it taken the latest code from the Git repo. That is what it said, like it has consumed one, right? So now let's see, the job has started. See, it started running. So you click on the agent job one, you could see what all the jobs it's performing. Basically, it's initializing the job, then checking out the parts unlimited. My code base is called parts unlimited, so it's going to check out the parts unlimited code base from the Git repo. Or if you connect it with any other repo, it's gonna do the same, right? So it's gonna do the same. Then what it's trying to do, so here you could see, like, it's gonna perform the NuGet, like using the NuGet, it's gonna build it. Let's say if it's get failed here, so this is the log. What it does exactly, it's gonna show you here. At every step you can see what exactly it does, and if it's getting failed, it's gonna show you where it got failed as well. If it's, let's say if it got failed here, it will gonna show in the red, and the pipeline shows like it's gonna be a failure. But in my case, like I have set it like everything as success, so that hopefully I would expect no failure would happen here. So everything is going good so far. So the testing is gonna happen here. Then right after that, it's gonna publish it. I mean, let's wait for a publish. See, you could see the time, how many minutes it's taking to publish. See, totally it has taken only 1 minute 21 seconds to do all this job. Just imagine if it's without DevOps, like how long it's gonna take in our daily life. Like, developer has to commit the change, has to take on the latest change from the Git repo, then they have to integrate with the build tools, they have to integrate. It's gonna be like, for me, like while saying itself, it's gonna be more than 1 minute. So, but with the DevOps tool, everything is happened within 1 minute. So the build shows success, right? Let's go back and see. So now previously you see only one consumed. Now you could see one more thing called one published. Basically, CI has published one thing. What it has published? Let's click and see. So it has published something like this. See, basically it has published a zip file. See, as I told you, right, this is nothing but your artifact. So what is artifact? A zip file. The end result of CI is basically a zip file. Basically, this zip file is gonna get used in your release pipeline or in your deployment pipeline. So your CI is completely done now, right? Your CI is completely done. So click on the pipeline. So you could see it got success. 3 minutes ago, it took totally 1 minute 26 seconds to run your complete pipeline, right? Now let's move on to the release pipeline. Click on the release pipeline. Again, I have something on my release pipeline. I don't want to use it. So let's create a new pipeline, new release pipeline, right? Create a new release pipeline. For now, I don't want to integrate with the Docker or Kubernetes to do the deployment. Let's see the demo with a plain normal flow. So I'm gonna say I don't want any template to be selected. Go with an empty job. So here it's asking a stage. What is your first stage? First stage I'm gonna say called development or dev. Let's call it as dev. So it's gonna be a dev environment. Let's create one more environment called test. So what is the, how we can create one more environment? Click on add, or you can clone it. I'm gonna clone it, and I'm gonna call this environment called test. And I'm gonna create one more environment from here called production. So this is the normal way of taking the code to an environment, right? So basically you have dev, first you are deploying in dev, everything is getting certified, then you will go to test, then you will go to production. See here, again, they have a pre-deployment condition. You don't want to automatically run and go and do a deployment production. You have a pre-deployment condition where you can set, I don't want deployments to happen in a production just like that. I needed, you can enable the pre-deployment condition. Who has to approve? Based on the approval only, you can take it to a production. Those things you can set it. But as I said, like I'm not gonna play around with here. So our demo is kind of focus on run the release pipeline. Next, you need to add an artifact, which means this CD has to take the artifact, right, from somewhere. Either you can take it from a build, from CI you can take it, or from Azure repository you can take it, or from Git repo or Azure Artifacts, anywhere else you can take it. So in our case, what we are gonna, we created one pipeline, right, like CI pipeline. CI pipeline has created one artifact. That artifact we are gonna use it. So I'm gonna select it, saying like, hey, this is my CI pipeline. Use this. right? All set. So next, what I'm gonna do, save it. So next, create a release. Don't do anything. So let's create. See, the release has created. So it shows the release has created. Basically, whatever the CI has come, like whatever you have created in the CI, it's taking that artifact and it's trying to go ahead and deploy it here. So if you click into release one, you could see it here. See, it got manually triggered. It got manually triggered, and these are getting queued. See, it started deploying in the dev. Once this is done, it will move to test, then it will move to the production. So now you may have a question, how these things can be, let's say if it got failed in the dev, how do I see it? Like if there is a logs. So you can see, and you can add any task you want. If you want to deploy using a Kubernetes, you can add as a Kubernetes task or a Docker task, you can add it, all those things here. That's part of your day-to-day activities. So you see, it got deployed in dev. Now it's proceeding with the test. Finally, it will go to the production. Now there is another thing. So here, currently we have triggered the CD manually, but we can go ahead and trigger the build automatically. Basically, whenever the CD created one artifact, it has to automatically go and deploy into the CD, right? How it's gonna do that? You can go and configure your release pipeline. So basically, if you could see here, see, it shows like a dev has been completed, test has been completed, production is ongoing. Let's wait for the production things to get completed. Yeah, so all this done. So with this, like, the complete automation, you could see it, like, if you want to see the test plans, either you can go and see the test plans over there, or the other way, you can see your test results. So you can see here, click on the runs, and you can see like how much report you have, see, this is what which you have shown. So it's going to show you like out of 16 test cases, 14 passed and 2 got failed, or 2 would not got executed. With this, I'm done with the demo. If you guys have any questions, I would like to take it up. If not, I'll hand over to Ganesh.